Hello, my name is Shubhendu Das and I am your mathematics teacher at Manata, and today I am going to teach you one of the most important topic, that is linear equation in two variables. And we have already completed 8 lectures on this topic, so we will continue today with lecture number 9. So in the last class we learned about the conditions, how we can check if there is unique solution, if linear equation has infinitely many solutions, or if the equations has no solution. So we will continue this today. So the first question, that is question number 1, find the value of k for which the given system of equations has infinitely many solutions. So the first one is kx plus 3y is equals to k is equals to k minus 3, that is the first equation, and then 12x plus ky is equals to k, that is equation number. Now we have to convert in this form. Ax plus by plus c is equals to 0, so it will be kx plus 3y minus of k minus 3 is equals to 0, and here 12x plus ky minus k will be equals to 0. Now this solution we have already written in this form: a1x plus b1y plus c1 is equals to 0, and a2x plus b2y plus c2 is equals to 0. So if we compare with a1x plus b1y plus c1 is equals to 0, and a2x plus b2y plus c2 is equals to 0. If we compare, you will get a1 is equals to k, b1 is equals to 3, and c1 is equals to minus of k minus 3, that means 3 minus k. Now it is equation number 1. Now from the equation number 2, what we can get? Here a2 will be 12, b2 is k, and c2 is minus k. Now here it has infinitely many solutions. So infinitely many solution means the condition should be a1 by a2 equals to b1 by b2 is equals to c1 by c2. Now just put the value. A1 is k, so k by 12 is equals to b1 is 3, 3 by k is equals to c1 is 3 minus k divided by minus k. Now here you have to compare first these two. So that will be k by 12 is equals to 3 by k. So here you can get cross multiply. If you cross multiply it, k square will be 36. So from here we can say k is equals to plus minus 6. That means k is either plus 6 or minus 6. Now this 3 by k is also equals to k minus 3 by k, because we take minus common. So 3 minus k by minus k becomes k minus 3 by k. Now k and k get cancelled. So k minus 3 is equals to 3. So k will be 6. Now k is equals to 6, and we can cancel this k and k. So or k can be is equals to 0. So the value of k is 6 and 0 from this, and value of k is 6 and minus 6 from this. So that means the common thing is that the k is equals to 6. So the value of k should be 6 in this equation to get this infinitely many solutions. Now the next one, find the value of k for which the given system of equation has again infinitely many solutions. Infinitely many solutions. So the equations are there: x plus k plus 1 into y is equals to 5, and k plus 1 into x plus 9y plus 1 minus 8k is equals to 0. These two equations are given there. Now you have to check that for which value of k it has infinitely many solutions. So first we can write this as x plus k plus 1 into y minus 5 will be equals to 0. In second equation, it is already in this form, so not required to change anything. So here a1x plus b1y plus c1 is equals to 0, we write in this form, and here a2x plus b2y plus c2 will be equals to 0, it is written in this form. So here if we check what is the value of a1, a1 is 1, then b1 is k plus 1, and c1 is minus 5. Now here a2 is k plus 1, b2 is 9, and c2 is 1 minus 8k. Now it has infinitely many solutions. So if it has infinitely many solutions, that means then we can say a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Now a1 is 1, a2 is k plus 1, now b1 is k plus 1, b2 is 9, and c1 is minus 5, and c2 is 1 minus 8k. So from here we can say 1 by k plus, or 1 plus k is equals to k plus 1 by 9. Again we can say k plus 1 by 9 is equals to, if we take minus common, so it will be 5 divided by 8k minus 1. Now you have to compare these two individually. So here what is given, 1 by k plus 1 is equals to k plus 1 by 9. So from here we can say k plus 1 into k plus 1. So k plus 1 whole square is equals to 9. So from here we can say k plus 1 is equals to plus minus 3. So that means k plus 1 is equals to minus 3, or k plus 1 is equals to plus 3. So from here we can say k is equals to minus 4, and here k is equals to 3 minus 1, that is 2. So two values are there, the k is minus 4 and k is 2. Now from the second relation we can find k plus 1 by 9 is equals to 5 by 8k minus 1. Now cross multiply 8k square plus 8k minus k, that is plus 7k, and minus 1 is equals to 45. So that means here we can say 8k square plus 7k minus 46 is equals to 0. That means we can say 8k square we can write this way also. If you factorize it, we will get k minus 2 into 8k plus 23 by middle term factorization. We can say it is equals to 0. That means k minus 2 is equals to 0, or we can say 8k is equals 8k minus 23. 8k minus 23 is also equals to 0. So this one 8k minus plus 23 is 0. That means k is equals to 2, and here we get 8k is equals to minus 23. So k will be minus 23 by 8. Now if we check, so k is equals to 2 and k is minus 4, k is 2, k is minus 23 by 8. So one number that is common, that is k is equals to 2. So that means k is equals to 2. In the value of k is equals to 2, it has infinitely many solutions. That means the system equations has infinitely many solutions. Now next one, if it is given, example number 3, find the values of a and b for which the following pair of linear equation have an infinite number of solutions. So now two equations are there, that is 2x plus 3y is equals to 7, and the second equation is a minus b into x plus a plus b into y is equals to 3a plus b minus 2. So two equations are there, and you have to find the value of a and b for which this pair of linear equation has infinitely many solutions. So now you have to write the first equation in the form of a1x plus b1y plus c1 is equals to 0. That means 2x plus 3y minus 7 is equals to 0, and this one is a minus b into x plus a plus b into y minus 3a plus b minus 2 is equals to 0. Now in this, so we have written in this form a1x plus b1y plus c1 is 0, and this one is a2x plus b2y plus c2 will be equals to 0. Now from here we can say a1 is 2, b1 is 3, c1 is minus 7. Now here a2 is a minus b, b2 is a plus b, and c2 is minus of 3a plus b minus 2. That means 2 minus b minus 3a. Now it has infinitely many solutions. It has infinite number of solutions. That means it should be a1 by a2 equals to b1 by b2 is equals to c1 by c2. Now a1 is 2, a2 is a minus b. Now b1 is 3, b2 is a plus b. Now c1 is minus 7, c2 is 2 minus b minus 3a. So that means here we can say 2 by a minus b is equals to 3 by a plus b. And we can also say 3 by a plus b is equals to minus common, so it will be 7 by 3a plus b minus 2. Now from the first one we get 2 by a minus b is equals to 3 by a plus b. Now if you cross multiply you will get 3a minus 3b is equals to 2a plus 2b. Now 3a minus 2a, that means a is equals to 3b plus 2b, that is 5b. So a is equals to 5b. Or we can say a minus 5b is equals to 0. From this to second part, that is 3 by a plus b is equals to 7 by 3a plus b minus 2. Now if we cross multiply 7a plus 7b is equals to 9a plus 3b minus 6. So here's 9a minus 7a, that is 2a. So 2a 3b, this goes to this way, so it will be minus 4b. 3b minus 7b minus 4b is equals to 6. 6 goes to the left side, it will be 6. Now it is equation, two equations are there. Now if it is equation number 1 and it is equation number 2, so you can put the value, you can get it. So a is equals to 5b here. Now put the value here. Putting the value of a is 5b here. So 2 into 5b minus 4b is equals to 6. That means here 10b minus 4b, 6b is equals to 6. B is equals to 1. If you get b is equals to 1, put the value here. A is equals to 5 into b, that is 5 into 1. So a is equals to 5. So you get a is equals to 5 and b is equals to 1. So the required values are a is equals to 5 and b is equals to 1. Now we have done lot of questions here. So now come to the revision section. We need to revise what we learned today. Actually today we learned few problems on this given theorems. So the first one is the find the value of k for which the given system of equation has infinitely many solutions. The first equation, kx plus 3y is equals to k minus 3, and second equation, 12x plus ky is equals to k. Now you have to write in the form a1x plus b1y plus c1 is 0, and a2x plus b2y plus c2 is equals to 0. So it will be kx plus 3y minus k minus 3 is equals to 0, and 12x plus ky minus k is equals to 0. So here a1 is k, b1 is 3, c1 is 3 minus k. If you compare, you will get this. Now in the second equation, if you compare with a2x plus b2y plus c2 0, then a2 is 12, b2 k, c2 is minus k. Now it has infinitely many solutions. As it has infinitely many solutions, that means the condition should be a1 by a2 is equals to b1 by b2 is equals to c1 by c2. Now just putting the value, we will get k by 12 is equals to 3 by k is equals to 3 minus k by minus k. Now we can say k by 12 is equals to 3 by k, and 3 by k is equals to, if you take minus common, so k minus 3 by k. Now from it, k square is 36. From the left side, you get k is equals to plus 6 or minus 6. From the right side, you get k minus 3 is 3, so k is equals to 6. So here from the first one, you get k is plus 6 minus 6, and from the right side get k is 6 means plus 6 and 0. So k is plus 6 is the value. The required value is k is equals to 6. In this value, it has infinitely many solutions. So the required value of k is 6. Now next one, find the value of k in which for which the given system of equation has infinitely many solutions. The first equation, x plus k plus 1 into y is equals to 5, and second equation, k plus 1 into x plus 9y plus 1 minus 8k is equals to 0. If we arrange it in the form of a1x b1y plus c1 0, a2x plus b2y plus c2 0, then a1 is 1, b1 is k plus 1, and c1 is minus 5. a2 is k plus 1, b2 is 9, and c2 is 1 minus 8k. Now it has infinitely many solutions. That means it must be 1 by a2 is equals to b1 by b2 is equals to c1 by c2. Now just put the value. You will get 1 by k plus 1 is equals to k plus 1 by 9. So k plus 1 whole square is equals to 9. That means k plus 1 is plus minus 3. So k plus 1 is either 3, k plus 1 is plus 3 or minus 3. If we take minus 3, k is equals to minus 4. If you take it is plus 3, then k is equals to 2. And the right side, you get k square, k8k square plus 7k minus 1 is 45, or we can say 8k square plus 7k minus 46 is equals to 0. If you middle term factorize the middle term, you will get k minus 2 into 8k minus plus 23 is 0. So that means k minus 1 is 0 either, or 8k plus 23 is 0. So k is 2 or k is minus 23 by k. Now from this first one, you get k is minus 4 and k is 2. From the second, you get k is 2 and k is minus 23 by 8. So the same value gives, that is k is 2. So the required value is k is 2. Now the third one, find the value of a and b for which the pair of linear equation has infinitely many solutions. The first equation, 2x plus 3y is equals to 7. Second equation, a minus b into x plus a plus b into y is equals to 3a plus b minus 2. If you write in this form, a1x plus b1y plus c1 is 0 and a2x plus b2y plus c2 is 0, you get a1 is 2, b1 is 3, c1 is minus 7. a2 is a minus b, b2 is a plus b, and C2 is 2 minus b minus 3a. Now it has, as it has infinitely many solutions, that means a1 by a2 equals to b1 by b2 equals to c1 by c2. You get 2 by a minus b is equals to 3 by a plus b is equals to minus 7 by 2 minus b minus 3a. So that means 2 by a minus b is equals to 3 by a plus b, and 3 by a plus b is equals to, if you take minus common from this, so it will get 7 by 3a plus b minus 2. Now after calculating, you will get a is equals to 5b, or a minus 5b 0, and the right side you get 2a minus 4b 6. Now putting a is equals to 5b, now putting the value of this in the second equation. So by putting the value of a is equals to 5b in second equation, in equation number 2. If we put the value, you will get the value, that is 2 into 5b minus 4b is equals to 6. That means 6b is 6, b is equals to 1. Now put the value of b in the first equation, you will get a is equals to 5b. So by putting the value, b is equals to 1, you get a is equals to 5. So the required values are a is 5 and b is 1. I hope you enjoyed the session. All the doubts are clear, and we will continue this topic in the next class as well, in lecture number 10. So thank you for joining the class. Bye everyone.